Example 2. Use the graph of the reciprocal function to determine and graph the linear function y equals f of x. Okay, so a couple things we need to know. Our vertical asymptote is negative 0.5. We know that if we're talking about the reciprocal, and we've got a vertical asymptote there, then our original function, that should be our x-intercept. Okay. Invariant points don't change. Okay. So we see that, and that is when y equals positive or negative 1. So that is going to be at x equals about, I would want to say like maybe like 1/4 3/4 ish. So negative 0.25 and negative 0.75. Okay, so we've already defined a bunch of points just with those two characteristics. From there, we can go ahead and approximate some other points. So if I say that when x equals, and again, I'm going to do a table of values for a couple things. When x is 0, it looks like y is for my reciprocal, it's a half. So the reciprocal of that, or to undo it, my original value would have been 2. Conversely, when x equals negative 1, my y value is negative a half, which means my original value was negative 2. So that gives me a couple more points to work with. Once I've got a couple points, it's as simple as just connecting them. So I'm going to take my line and extend it upwards, and I'm going to also extend it downwards using a ruler, and that is going to be my x. So we use our vertical asymptote, becomes our x-intercept. We use invariant points when y is positive and negative 1. And then we can choose some other relatively decently defined points in order to figure out some whole number original values. We like whole number original values because then they're easy to plot on our graph. Okay, that's how we do example 2. So you've got lots of practice questions. I will have a video kind of running through the other two parts to example 1, so not to worry.